up today with introduction to using and scaling Dagster. Here are Georg Heiler and Aleksandar Milicevic, senior data expert and data engineer at Magenta, will walk us through this introduction. So the stage is yours, guys.
Perfect. Hi, nice to see you. I guess that I will start to share my screen and I will start the presentation. We will do a bit of introduction, what we want to do today. Then we will introduce ourselves and then we will jump into a demo and I would say bigger questions maybe at the end or towards the end. And we would also like to encourage you to ask us all the questions along the way, because I guess that this is a kind of more tutorial session and not just a presentation from our side. So I think that we can also spend a bit more time to discuss why we are doing this, what we were showing or what we are showing, and then to discuss more into detail and how we use Dagster, I would say at our home, at our work.
For the demo, it will be hands-on. So if you want to, you can actually follow and join and explore for yourself. And maybe to test that the audio works, can someone of the participants say hello so we can hear someone?
Yes, maybe we could start.
I don't know if people from participants can also talk in this session. Maybe the host can.
Participants can only use chat for now. So, I mean, so.
Okay. Is this in general so, or this is something what we can change, or this is for us? It's both are fine, but just from the side of.
It's something in general.
Okay. Okay, fine. Then I would argue that whoever is not presenting is observing chat. Yeah.
Yeah.
This is something what I would ask then Georg for, at least for the beginning, you and maybe host, you can also try to follow it and stop us if there are some questions along the way, because I think that it's better if we are interactively doing this and not only showing something and then don't know at all. If there are some questions, maybe it's better to stop and try to answer them on the way. Okay, saying that, let me start. What we want to do today is we want to introduce how we use Dagster, and towards the end of the session we can also discuss how we use Dagster at Magenta. If you take a look into today's agenda, we have 1.5 hours, if I'm right. So practically, what we will try to do in the beginning is we will start with a talk about what is a data platform at all, what is a data platform at Magenta, and what is the role of the Dagster. So starting about why we are using Dagster in the first place. Then we will, in the second part, and this is something what Georg will present, is we will touch a bit more about Dagster main concepts, which we think that are important for people new to Dagster, and also try to compare Dagster to something what you know from other tools. Then later we will go to the hands-on lab. We will go through the folders. On the beginning of the lab, we will try to spin up the environment. We will show you how you can do this in the GitHub code spaces. We prepared the repo and a GitHub repo, and then you can follow with us. But we will mainly show the folders, go through the code, and maybe change something together there. And at the very end, we can discuss Dagster at Magenta and what this means, and where you can actually interact with us, and where you can learn more about Dagster at Magenta, and also see I would say not such an enterprise solution as we use in Magenta, but something that we could show outside of Magenta and have in the open source world. Okay, who we are? We are today with me is Georg. The newest description of Georg is data expert, but what he is also, or what he is actually doing is he is an architect, and I would say a visionary behind our data platform, and everything what we have there is, I would say, if not fully, then partially came into the picture first time with him. And me, my name is Aleksandar, and I'm data engineer at Magenta, and I'm there for around 2 years now, and mainly leading the development of the data platform in Magenta, and this with specialization, I would say, more on this data engineering part. There are also other people who are more, I would say, concentrated on other sides like governance or AI platform, but I'm actually, I would say, not only, but mainly working on the data engineering part in Magenta. Okay. If we start the story with what the data platform is, and if we just say this in one sentence, is that data platform is there to help understand business process and improve service. This is very important to kind of realize that we are not doing this for me and Georg and other people who like technology. It's more because we want to improve the service of Magenta. What I realized till now is that I never said what Magenta is. Magenta is a telecommunication provider in Austria. It's practically a branch of German Telekom in Austria, or maybe you know it also as T-Mobile. You can think of any provider, telecommunication provider in your country. I don't know where you are from, but in your country. If you take a look now into the what data platform is, we can see that somewhere in the world there are customers, and what you would normally have in such enterprise environment, you will have some application. This application can be everything specific to a telecommunication, but you have also something like Magenta Moments on the phone, but you have also a receiver next to your home where the connection is actually going through. And practically you can imagine that customers are somehow interacting with whatever service Magenta is providing. And what you can imagine is that every service and everything what Magenta is providing has some type of database, some type of saving the information in the background. This is not only specific for Magenta. This is actually in every and each enterprise that you can or you have in the world. What you also will see is that there is a business unit. The business unit is actually the part of company that is following the operational world, so called, this world where the customers are interacting with Magenta. And you can imagine that business unit is actually controlling how the operational world works. So practically you can imagine that we in Magenta, we have receivers for your cell phone, and we can say, here in that part, we have a lot of customers who have 4G, and then we want to provide them a better connectivity, then we have to put there the cell with 5G. This is something what a business unit would control and implement. In order to be able to say something about the operational world, we have to create a report. And the first thing when you think, okay, I'm creating the report on the operational world, we are creating it in order that the business units understand the operational world. But in the moment when we start to implement the reports on top of the operational world, the data load starts to overload the operational world, and this starts to overload the system that are interacting with the customers. So practically we can say that we don't want to do this. so to create reports on the operational world databases in operational world systems. You can do some of them, but not everything. So practically you can imagine that, yeah, it's slow or it slows down, and deleting it and then installing it again, this doesn't help. We have to actually think of another solution, and this solution is practically to offload this reporting and this part of the platform working with the data to some other place that is actually not making overload on the operational world. So practically what we'll do, we will export the data out of the operational systems, and then on top of the data platform, whatever this is right now, we will create the reports and we will provide the business units them. And this is now fully separated from the operational world. What you also can imagine is that there are, for example, some third parties, external parties that are observing Magenta, and we can also use those reports to kind of justify stuff to them or the data to them. You can imagine that data world is not only there to be there. There are a few different reasons why you would actually offload your data processing out of the operational world. Like, for example, this is a totally or fully different technology, which is more specified for such types of load. And what is also important is that this is for historical load, or that a company has to understand the data as every and each asset. Magenta has the cables in the ground, but we also have the data that is really powerful and has a lot of insights inside of Magenta. Okay, this is the first part, why data platform exists as the whole picture. What is important also or interesting is that if you do it right, you could then actually start to push back stuff to the operational world, and you could provide some AI products and AI insights towards to operational world applications. But this is again one aspect of the data platform which can be or is interesting at the very end. If we go further and start now to deep dive into what is a data platform, and if we ask ourselves, okay, let's imagine I want to create a report, and I want to make a very simple end-to-end pipeline, end-to-end reporting. What I actually need, and this is now what we want to discuss, is what would be needed for this to work, is you would need a computer with whatever operational system you have. Then you would need some storage, which is on that computer, but or should not be, but storage as a component. You need some type of transformation engine, so practically how you can transform the data, maybe read the data from somewhere and then save it into the storage and then do something with the data. This can be a Python process. Then you would need some very simple visualization methods. For beginning, we can start with matplotlib, very old one, but useful. And what you also need is an orchestrator in your data platform in order to say every day at 5 in the morning, I want to read from that REST API, transform this data and show it in my matplotlib graphic. And this, if you now take a look just for a second, this would actually work. I have a cron tab schedule. I have a very basic computer with a storage disk on this computer. I have Python installed, and I can just create an end-to-end report. But if I go a bit further, and if I say this will not work for enterprise scale as Magenta, or this would or should not work like this for any business you have or is working with the data, the question is now how I can make this last. What is actually needed in order to improve this process, that this process is actually not only working, but also working for a long time, and that it's extendable, and that it's actually makes sense from the component perspective. If you take a look into data transformation engine, we can go with whatever other transformation engine, something what has ACID from the perspective of configuration, so that you can that you have transactions, that you are not working only with the files, that you have some specific transformation engine. This can be DuckDB or Spark, or if you go to BigQuery, whatever works with data transformation. Then from the infrastructure perspective, you can imagine that you would maybe go to some cloud provider. We at Magenta are in Google Cloud, but every provider is fairly similar. Then for the storage, you would normally go with some distributed storage, which is kind of from your perspective unendless in that sense. And for some data visualization, you would go with some enterprise tooling. So now you can imagine that also what we should do is to adapt our orchestration, and we could go for whatever orchestrator is actually provided outside, for example, Apache Airflow or Dagster. And looking in this picture now, this is exactly the same picture as the beginning. We have exactly the same process from the perspective of at the very end is some report or some visualization, but you can already see that this is more sustainable, and that this is something what could give you a scalability and some type of security for your business working with data. But nevertheless, there are also other components which could be useful here. Like, for example, we could also use some data transformation framework. So something what you could use to more easily work with the data and extract insights. You could also have some metadata view and governance on top of the full platform in some sense of data catalog, like, for example, Data Hub or Collibra. You could also have a modeling tool, which is actually showing your model, and that is actually governance before we go into the development process. And of course, the very last part, which should appear on every slide, is we can put then also AI tooling on top of this, whatever is there outside. And we can take whatever tool, but it's important that in some sense you have that tool in your platform. Today, I would say we will speak about the Dagster. And what is also important is that we as Magenta, we take a look and could speak and discuss every of those components. And I think that from the data engineering side, we are fairly, I would say, we introduced all the components you see now on the screen. From the perspective of data transformation, we are using dbt. For data visualization, we're using Tableau. For modeling, we are using Innovator, and so on. So practically, we have all of those toolings inside of our data platform, and we are already in a fair use of them and have some experience with them. Let us discuss now about Dagster and why we actually decided for Dagster itself as an orchestrator of our data platform. Looking into the picture, on the very left side, there is some source data. Then what normally happens is that you would do some data ingestion. Then when you ingest your data, you would do some data transformation on top of this data, create a new table or some very last table, which will be then used in the further downstream reports and use cases. And of course, this all should be orchestrated somehow. If we take now a developer again, and we say today in this world, so if I'm on some vendor or cloud vendor, and if I just asking myself, how could I do this? this would look something like this. I would have source on the very left side, and I will start to ingest my data. I would pick one of the tools. This is one tool where I go and I take the tool, I ingest my data, and I bring my data somehow in my either data warehouse or storage plus some catalog. So practically all the variations are fine. But ingestion is the first step. The second step would be then data transformation. You would write some transformation pipeline that is either in the dbt or a Jupyter notebook in the Apache Spark. And then when you're finishing your transformation, you would then go to one orchestrator and you would go there and set a timer, set a task, and say, hey, I want at 5 in the morning to run my Spark job, or I want to run dbt run select whatever model is in the dbt. And then at the very end, you would go to Tableau or Power BI and you would say, at 8 in the morning, because I know that between 5 and 8, my transformation should be done, my pipeline orchestration, I then go to my Power BI or Tableau and I do a schedule for refreshing the dashboard, for example. How is this in our case, or how this looks like in our case, and where the Dagster actually shines, is that we were picking or taking the Dagster as a backbone of our project, so practically of one process. And what you can then see is that for the data ingestion, and this is intentionally like this on the picture, is that you can see that for the ingestion process, we have actually Dagster plus Spark with some configurations files. If you go on and do transformation, you will see that we have dbt, but dbt is actually integrated inside of Dagster and sitting on top of the Dagster. So it's not, I don't have to go to a Dagster and say, please run for me this and that dbt model, but I just go and create a model, and model is taken away. And this is something that Georg will speak more into detail, and we will show this, how this works later in the tutorial. And for the very last time, we have also Tableau integration. This is something that we as Magenta also contributed in Dagster ecosystem a lot. So practically, at least from the feedback side, that when the dbt model is ready, then it can go or refresh the Tableau. So practically, you can imagine that instead of 3 hops or maybe 4 hops, in the old or in the current world, how people are normally working. So from the data ingestion tool to the data transformation tool to the pipeline orchestration to set up something, and then for the refresh in the Power BI, we actually have everything on top of the Dagster as an orchestrator, and every and each tool is integrated inside of the process itself. Saying that, I would hand over to Georg. That Georg now speaks. Will speak about the Dagster concepts into the detail, and the most important concept, which is actually asset-based orchestrator, and what this means. And then later, I will again do a part of the tutorial. So, Georg,
and maybe we can stay for one more minute on this last slide. I think one point that it's more important also to stress here is that in our case, all of these individual tools are living in a single.
I'm sorry to interrupt you.
Yes.
George, you are really silent. If you can make you a little bit louder, if it's possible.
I don't know if I can do this because it's the microphone of my MacBook.
Go near to the computer.
I only have this one microphone, but I can try to talk really close to the microphone. You look into my
That's
nose.
better.
If that is better, then we will try that approach, okay?
Thank you, Georg.
So what I wanted to say is, I hope you like my nose, is that in our case, the individual tools are living all in a single repository. So if there's any feature to be implemented or any change request to be changed, And this is a rather simple thing for people to do, because all the relevant things from basically ingestion to visualization can be tackled in a single context. Especially now when we developing the main or new role of context engineer and AI, having a well-defined context also leads to better AI support. This is, I think, an interesting principle to consider also when building data pipelines. Because what is easier for the humans is usually also easier for the machines to reason about. Now, let's move over to the next slide, Alex. So for us at the Magenta, we chose that we want to construct our data platform with the orchestrator at the heart, not with any engine. Like in the past, for example, our main engine was Oracle, and it was already a problem because it could not ingest data on its own, let alone do AI. And we understood our lesson from the past and our learned this lesson, that we have to have great engines, but they cannot be at the heart. We have to be able to flexibly choose and mix and match the engines. We need something else, something more flexible at the heart of the data pipelines, and that is the orchestration tool. In our case, we have decided for Dagster for various reasons. And during the course of the talk, you will understand more and more why, for us at least, this choice made a lot of sense. We are using the hybrid deployment here, where all the data stays in our own Kubernetes deployment. We can use software engineering best practices for the deployment of the data pipelines. So it's not just random SQL snippets floating around. If someone from the business wants to contribute something using, let's say, dbt, for example, they can do that at any point in time. They raise a merge request, and then when their SQL is basically automatically on one side part of the scheduled pipelines, and on the other side part of the CI/CD chains that fully tested go to production. And
Yes.
last but not least, and I think really importantly, we have this asset-based mindset for the data flows, which then gives us a calculator-like structure for handling data dependencies. And if you think about multiplying numbers, you know that the computer is really good at this. Usually the human brain is not so well suited for doing that. And it's exactly what happened with the data dependencies. In the past, for example, on-premise, we had limited resources, hundreds of pipelines that were somehow interleaved, and we needed some, in fact, way too much human brain power to somehow make the dashboard load at 9 a.m. with fresh data when the CEO wanted to see the data, albeit with restricted resources and basically very limited data quality, and then various services that delivered data at different times of the day. Now, with a graph-based orchestrator, the machine can take care of all of this. And how is this enabled? Well, it's by working with and constructing the whole data pipelines around the asset graph and metadata first. So it's not reverse engineering any metadata and then figuring out there might have been some data dependencies, but it's about directly architecting with these data dependencies in mind. You can see at the bottom how such an asset graph in at least small demo example looks like. In our case, on the very left side, we have some ingestion processes where they are running the Spark or Python code to ingest the data. In the particular example that Alex mentioned before with the REST API, we will later also see in the coding example how this can be done. And I think it's quite an interesting and a very common example. Then we have something in the middle that is doing transformations with dbt with SQL. In our particular case, that is built around data vault. So a lot of joins and in a graph-like data structure on the logical level for itself. And then we have a serving layer. In our case, serving for BI is taking place via Tableau, as Alex already stated. And we want to make sure that Tableau can be integrated without people having to manually do this integration. For this, we talk to the REST API, but more about this in a couple of minutes. So what we have now is the asset graph, metadata-driven pipelines, and basically reusable objects. Can you go to the next slide? We want to make this more clear in a small cookie example. And imagine you're at home, you wanna bake some cookies, you take the ingredients, maybe butter and some meal, oatmeal and whatnot, and chocolate, obviously, to bake chocolate cookies. Alex, can you already advance the cursor and then eggs and flour? Yeah, I'm not the best cooker. And from there, we will showcase in two variations, task-based and state-based, what this means. Task-based is the traditional means how something like perhaps Airflow would have worked. So we would combine the individual items and then have something that is cookie dough, not yet with chocolate. We might add then chocolate later to this thing and then put it into the oven and bake it and eventually have the chocolate cookies. But as you can already see when Alex is hitting the next button, the graph structure that we see forming here is very much unconclusive when we look at the task-based graph that is forming. So when we connect the blue boxes, we see something is combined. We don't know what is combined. And we see something is baked in the oven, but we don't know what is the output. If we instead look at the state-based approach and then combine these ones, we actually see also as humans what is going on. And seeing what are the friends and friends and friends, like in Facebook's graph, here in our case, the data dependencies, the machine learning models, the tables that are connected, is a really powerful feature to have. And we can derive some interesting properties from that. Let's move to the next slide to make it more clear what these properties are. So let's juxtapose these two variations of the same thing. And again, the blue one shows the steps that happen behind the scenes. These same steps are also happening in the graph-based representation. However, the graph-based representation makes it more clear what is going on. It's basically showing us the states that are materialized, so the things that we care about, if they are healthy or not. Whereas the task-based approach is just opaque to what is really happening, especially to the things that we care about. So one advantage is testing. In the graph-based approach, we can add a test to the individual node in the graph at any point in time. In the old world, this was not possible, and we had to add tests without a lot of framework and coordination. And this is really, really cumbersome to take care of, especially when it comes also to sometimes resources not loading the data at the same point in time. Coordinating when to load what leads to a very messy situation where sometimes all the jobs are triggered, sometimes for empty data. And this is just not, when for people that want to consume the downstream output, very much unclear, is the data now fresh and of good quality or not. Here in our case, we can do the testing at every point in time we want to do it. And the same goes for freshness checks. So we can also add these to the nodes as we see fit, check if something is delayed or not, and then send notifications. And even more than that, imagine not just a graph of 5 or 10 nodes, like we have it here in the example, but a graph of hundreds of thousands of nodes. This is actually a common scenario for enterprises. I think our data warehouse had around 30,000 to 50,000 tables alone. So, and more so transformations going on between them. If you want to coordinate this, you inevitably end up figuring out that some use cases have dependencies on some other use cases. And if you have to hand resolve this in your head, this is going to be really, really messy. Instead, if you can choose this graph-based approach, you can work with event-based scheduling, or here in the world of Dagster, we call it declarative automations. You can specify individual items in the graph should refresh based on the size of your credit card or specific needs to save money, perhaps, and then basically call it a day. This is much more simple and basically what you would want and expect from the graph instead of what you would get when you were working with a task-based orchestration model.
Here is really important to say that those task-based orchestrators, this is something what you would see in the Airflow or maybe some others, and now and I would say in the Airflow 3 they introduce something similar concept as the assets in the Dagster. So practically the thing is that from the beginning to the end, it's always the same job, but the difference is just how we think about the specific points in the graph. And if this is the task-based, then the points are defining the tasks, but the input and the output is actually not explicit, it's not written, but it's implicit, like it will happen. And then throughout this, a lot of valuable information is actually lost in the data orchestrator. So practically, this is very important to see that having asset and having only thinking about how assets are drawn on the graph, you will be able to easier understand Dagster UI later. This is very important to see. Okay.
So Alex briefly also mentioned scaling a little bit. Scaling means having many people collaborate on one side, in another dimension perhaps working with large quantities of data. Especially for an enterprise, we are more concerned with the first dimension usually, and then making many people work effectively with data, people and machines. And a key ingredient to this is to work with metadata and work with machine readable specifications and contracts of this metadata. In our case, we have a sample project or pipeline testing project where the main, let's say, advancement and future development of our data platform takes place. You can see a screenshot of this downstream here. Has more than 50 models by now with some data vaults, some visualizations and whatnot, just for this dummy project. But the interesting thing is we have to make sure that the core data engineers are not required to add something to the orchestration graph. So we work with this machine readable metadata. For example, for the ingestion framework, we have some YAML files. We will look at this in more detail in a minute. And it always is the same approach. We collect the metadata in this pseudocode approach on the left, have a for loop, iterate over the metadata items, and then add nodes to the graph. So this allows us to take what people from, let's say, the business department or the analytics engineering group or the marketing that just apply some SQL practices have done and bring it into the very much professionally orchestrated environment. Let's look at some of the examples. I was already mentioning the ingestion configuration. It's a folder with some YAML files for what should be ingested from Kafka, from JDBC systems and whatnot. And we are creating the assets in this way. In our case, here we're using Spark for reading the data and then writing it to the destination data warehouse. But besides the ingestion, one of the even more relevant integrations is the one for DBT. Here, the heart of the system, so the logical data transformation via SQL takes place. And people are basically contributing, also reporting SQL snippets. The metadata of DBT is already very much structured. And then the orchestrator can just interpret that manifest.json file and then bring it to life. It's not only about, perhaps if you go one more point back, Alex, it's not only about running what you see here. So in our real DBT integration, we have further add-ons. So for example, a DBT run might be accompanied with a DBT test, and the test information will also be collected and then pushed to a data catalog where we can keep track about how the health status of the data assets is changing over time. Or perhaps if there might be some inventory system or whatnot, we can then do something in addition with this metadata once the particular node in the graph is refreshed.
But what is very important to say here is that this is written only once. And then how I would actually extend my graph is adding a model to the DBT project. And then the Dagster would actually extract the new manifest and would put a new object on top of the Dagster UI.
Exactly. And this is something that enables, or in fact empowers, less technical stakeholders that prefer to talk only SQL, but not want to understand the data dependencies before and after them. So it is a key component to eventually enable also more self-service like architecture. Let's move on. Here you see the Tableau integration. Tableau is a system for BI and visualizations. I guess it's really common in this group of people here. Maybe you're even using it in your company. And usually there at least for us, in the old way of working with Tableau, we had the challenge that the data was updated usually only daily, I think around 10 a.m. in the morning, and either the upstream data transformation was ready or not, and when certain extracts were executed, either with now bad quality or not fresh data. It was more fire and forget. This is certainly not ideal for quality, and also not for latency working with data. The integration that you see here is bringing individual Tableau dashboards into the graph without added effort. So basically, this is an open source integration. You can pip install it on your own Python environment. It will talk and connect to your Tableau servers API and then bring the graph, the Tableau dashboards into your graph as well. And individual dashboards will then be refreshed when the upstream assets are updated. I saw one comment in the chat. I don't know if we have to address this one here.
I don't see the because I'm not sure if I.
So the comment was, let me
sharing.
read it. So lately Magenta has made a partnership with N8N. What was the key factor affecting the decision to use Dagster over N8N as a workflow orchestration tool in the data reporting area? I think there are many workflow orchestration tools. This particular one is based around being a high, less code and high UI orchestration engine, mainly targeted as low-code AI integrations, which is nice for someone, let's say, exploring and drafting something like a prototype quickly, or perhaps for business stakeholders that want to connect their Google Drive with their Slack. However, we are an enterprise. They don't even have some of these services, for example, Slack or Google. So for us, we think that for some use cases, maybe having something like that, which connects with building blocks to internal services, would be a neat thing to have. But for us as the core data warehouse, which is currently mainly focused on enabling this reporting infrastructure, enabling the AI and MLOps platform, it is more relevant to have the flexibility to empower many people, but work around software engineering practices to actually scale. So we are working code first, metadata first, and we sometimes, in fact, not just sometimes, often face various restrictions. For example, one is when interacting with Kafka, we sometimes cannot directly talk to the schema registry, but have to get an authorization token from a different service and whatnot. So there are so many challenges that come up that usually do not make the pre-made connectors that are available in this low-code solution a good fit for what we have to do. And when we go to the next slides, you will learn also about a couple of components, these reusable components, which make it really, really interesting to actually choose Dagster. But I think, Alex, you wanted to also add a part or to that answer.
I just wanted to say is that what we also have to understand is that Magenta is big in that sense, that there are a lot of departments and a lot of different parts of company who are actually, or who have the different needs. And this is what is also lying to your answer, is that we are currently in a data warehouse development process, and this is our need, and that such a low level tools are more for some day-to-day automations and so on, and that we are actually working with the frameworks who are helping our data warehouse developers to develop faster, to have more productivity, more quality, and so on.
But perhaps one thing to add here is, albeit we're currently focusing mainly on, let's say, traditional data warehousing, we are also building an MLOps and machine learning platform and GenAI platform on top of this single system here, that is a unified overall solution. And we are also basically, when talking to the business, tell them we do not want to show you the cold shoulder and give you a lot of space for shadow IT. We actually want to take this very great scheduling system and make this accessible for a large amount of people. We have created many integrations that also play well by the governance rules that we have chosen. And we want to enable people to choose the happy path, which in our opinion is the right path to make us collaborate effectively at scale in a larger organization. But how does this look like? I was already mentioning the components. So components in Dagster are these nodes, but that is just the logical abstract thing in the graph, right? So I told you the nodes are the state that we care about. That means at some point the state has to be materialized somehow. In Dagster, to encapsulate reusable logic, we have basically three ways of doing it. One is the traditional Python library that you can at any point use, but another two options are resources. Sometimes you have to talk to an API, and we will also see that later in the tutorial. Perhaps you have to have a password or some parameters that are different between dev and prod on test systems. And here, using resources can be a way to neatly parameterize the resources that you want to use and also make the data pipelines testable. And talking about making things testable, when it really comes to materializing the output, the I/O manager is the key piece. Let's imagine a database I/O manager. Perhaps for development, you might want to materialize to DuckDB sitting on your laptop, but for production, you might materialize to DuckDB sitting on S3 or perhaps to, let's say, BigQuery instead. With an I/O manager, you can make the large and complex and in fact distributed system shrink down to the developer's laptop. This not only can increase the speed of onboarding new people, but also allows you to debug more effectively and can help us with regards to context engineering, because what this allows us to do is dependency injection. I don't know how many people in this round are Java developers or have a background in Spring Boot. But if you do, you are very familiar with this term of dependency injection. If you don't, it's basically an inversion of control principle. And that means, I think the easiest is I explain this with the example below. I don't have to care where these reference addresses come from as a user. I want to just have the system inject them to me. So as a data scientist who might not know about where this is coming from, I can just write this function and say, hey, give me a pandas data frame, or if I/O manager supports it, a polars or Spark data frame, and give me all the fresh data of this particular kind of data set. And then I can work with it, right? I can do a linear regression, I can run my ML model. And the interesting thing is, by having these reusable components, we can abstract a lot of complexity. So there is certain complexity in engineering a platform, and this is usually not the complexity of a business logic or the AI logic, and in different personas usually cater well for solving these challenges. And here you can abstract them and then take people in the business and then let them then perhaps even vibe code their business transformations, but in a way that is actually productionizable. And this is a powerful pattern. One example from Magenta, when we are planning our network rollout, we have a big Excel sheet, and then we allocate resources, actually a lot of money, on where and how much new cell towers should be built. In recent years, people were exploring to do this with Python, when we got some interns and then they put together certain great Python sheets, but it was not productionizable. It was still running on a single network engineer's laptop. But with a system like this one, you can actually, once the reference data is there, so usage patterns of a network, the energy consumption, maybe the plans of the city of Vienna on how to build the city in the next 10 to 20 years, you can basically feed all of these into a function like you see here in the slides and say, give me the pandas data frame of these individual data assets. And from there, the business people can easily integrate their particular business logic in order to do the maybe even vibe coded processing of the data. So
Yes.
that being said, let's move towards the demo. We will start with some very basic things. Alex will mainly lead through the demo. I have already shared a link in the chat, and maybe some of you have already opened it. Maybe we can get a couple of hands raised to know if we will just show the demo or how many people will want to actively join us, so we know how fast we should move. But from there on, I would say the word is with Alex for this next part of the presentation.
So just let me see this and maybe
Wait,
moving
Alex, before
to...
we start here, there was one more question. Could you go back to
Yes.
slide 12?
I would like to answer, to give time for answering the questions.
So the
This is,
question
I
was,
guess, the
how do
point.
you scale the query shown on slide 12 for ML projects? Is this a big bottleneck? So the particular query is the one that we see here on this slide. Obviously, this select star from something is maybe not an ideal query for a large table. So the first thing how we would scale it, we would actually try to inject it into the top and have an IO manager that is only feeding the particular relevant partition of the data, which is ideally just latest. If it's a sliding window, maybe it would give us a tuple or iterator of the last 3 instances of whatever latest means. So today, yesterday, and the day before yesterday. So this is already massively reducing the data. The second way of how we would scale it, we would create IO managers that don't not just talk pandas, but they might talk polars or DuckDB or whatever is multi-threaded and more efficient in working with data. And obviously, if it makes sense, we might even create a Spark run or use an MPP database, let's say BigQuery or whatever cloud data warehouse you might be looking at. Is this an answer for the question? Or Alex, is there something you would like to add?
I would like to understand what the bottleneck really would be in that sense. This is only so practically this is I would say a connection to the big query which is set up in the background and pulling out some data for the for some use inside of this asset. This is a kind of from that side. This is the process how you would do it. You could, I don't know if the import or so export from the data or import into the process is bottleneck or so on. So maybe we can discuss this later. But as Georg said, is that normally what you would do is you would try to chunk your data and then do it on a smaller pieces. So practically to
or perhaps
to
in
have
other words, like data accumulates over time, thinking in partitions and in continuous streams of operational processing makes a lot of sense. Even if you think at log data, the data that you care about is the anomaly, not the normal log. So it's only a small set of the data that you actually want to retrieve, perhaps doing some processing. So thinking about how can I effectively work with this medium, usually data sized data set can make a lot of sense, especially also with regards to cost control. But I guess
okay.
let's move over to the demo now, and
At least I would like
there's
to.
an explanation now.
Seems
You
like
see,
sense on my
data takes a
conversation.
long time with
Yes.
statements.
This is correct, and this is true. This was also not intention to think about this in that example. It was more from the perspective of this is the resource and this is how you can inference whatever query you want. But this is correct, and this answer to this would be that you move your process in near to the BigQuery as much as you can, and don't use pandas. So practically,
I mean,
those
there's
are
also, I think,
some of the.
how is it called, big frames or something that gives you some via IBIS or something, a Panda style API, so people can use their Panda skills, but in behind the scenes it will talk SQL to the database.
Yes.
Um,
So I would like to go on. Maybe just into the chat, who would like to do this with us? I would say, or I can maybe show it shortly how this would look like. So practically what we have here prepared for today is we have a GitHub repository which is in the organizational MDS. This should be a public one, so maybe somebody can confirm that you can see it. You should be able to see it. And what we want, yes, perfect. Thank you, Trajan. And what we then want to do is we want from you, if you want to do it with us, because I think that it makes sense, because I also provided some small task. We can also maybe discuss it then. I would also really like that you could that we could hear you, because I think that it would be much much more interactive, but it's fine. We will survive. So practically, what you can do, or what you should do, is click on the code, and then creating your code space. I already accepted everything what is from the code space side, so I directly jumped onto the code spaces, and this should start the environment and install everything what you need to be able to run examples together with me. So this is something what you can do, and I guess that this will take maybe a minute or two. Maybe we can answer another question while this is loading. Huh?
I mean, there might be questions on how to set it up and so on.
No, I mean the first step is to click here on the code, to go to the code spaces and click the create a new workspace, and then the workspace will be created in few minutes. So practically it's downloading.
Alex, you could show the ... if people click the ... and they create code space with options. There's a possibility. Yeah, the first one exactly. If you click this one, there's a possibility to select more resources. So machine type at the bottom, you could use 4 cores. So if you,
but I don't think that this is needed, at least for this.
Yeah, so if you're working with big data, right? At least, or if you think you're working with big data, you can choose that option.
Yes.
Anyways, for the sake of this tutorial, the basic one should be sufficient.
I would like to go, okay, just a second to find it locally. So I can start already to this. If somebody is confirming me that somebody is working with us, or at least trying this with us, just to see if somebody is following, in order that I can ask if this or that works. Workshop here. LS DSC DACH code dot. Okay, this should now be open in the code. So practically what I just wanted to do is, before I start whatever in code workspaces, this is exactly the same code locally on my computer. You can also, if you don't want to use the code space, you can also git clone it, but you would have to have Pixie. And I'm also not fully sure if this works on Windows. So at least I didn't try it on Windows.
Should work.
So
it should work.
It should, but maybe some parts or something is not perfectly aligned in the background. So I don't have Windows from that perspective.
We tested on Linux and we tested on Mac, and it should support.
And in the code
OSs,
space,
but
yes.
As Alex said, some paths on Windows might fail.
Exactly.
The easiest way to try it will be via code spaces.
Okay. Let me maybe go to a picture that is actually explaining Magenta stack, and I would say what actually we have at Magenta, and then what is in this example. So practically, if you imagine the full stack, what you would see is that we package everything in a Docker container, but what is more important is that we are using Pixie as our package manager. Pixie, so you can see it here. So practically, I would not bother right now too much about Pixie, but you just have to be aware that we are using Pixie as a package manager, and saying that it's one command to install everything and to start Dagster. So if you would like to learn more about Pixie, you can do it later, but you can imagine that Pixie is sitting under the process, so practically on the environment and managing the environment. And what you also have inside of this repository is Python that will be installed with the Pixie together, and then Dagster that is installed with the Pixie together. We have also other stuff in our environment, but those are not important for us. And what you then see, and I think that the Git code spaces are open. So can somebody setting it up? We'll try to follow it through via code space. Perfect, Ermin. Thank you very much. Did somebody or Ermin, did you made it work? This is the question. I will make it bigger. So did it load for you? This is the question. Yes, perfect. Okay. Then let me try to walk you through the code. So practically what you will see is that in tutorial source, you will see the tutorial package, and then under the definitions, you will see different folders with different topics that we want to cover today. What we want to cover today is still 4, so practically first 5 folders. And with this one, I think that you will already be enough advanced to imagine how those basic concepts are actually building up and how we use them at Magenta. So once more, is that you have the source as the root folder, and then you have a PyProject.toml that is defining some environment and the workspace from the Dagster. Workspace meaning that in the source there are multiple Dagster projects, and one of those projects is the project tutorial. And then one Dagster project and one Dagster code location that I will explain in a second is in the tutorial itself. And what you then should do is you should go to the tutorials and run pixie run-dev start. This is the only command that you need to do, and I hope this will start the project or the project at your side. So if you want to copy this command from there, you can copy it from the README, but you will have to navigate to the tutorial. So practically you will have to do cd src tutorial and then be there. Okay, the first thing, perfect. Okay. So now clicking on the 3000, so practically you can see here that something started, or Dagster started on the port 3000, and clicking on this, you could now imagine what happened is that Dagster as a server started, and that the code location is loaded, or practically that all the examples that are written in the folder from Dagster are loaded into something what is called code location. Okay. What I would really recommend, if you tomorrow would start to look again into Dagster, and you would be interested in more or going deeper into the concepts, you will see. So practically, this is the Dagster documentation page, and I would argue that they have really good documentation about what is there in the Dagster. And what you can click or could see later is the concepts on the Getting Started page. There are also other pieces of documentation which you could look later. But in my opinion, the most important is the concepts one. The first thing what we will see is that you will have something what is called asset. This is the first concept. One asset is actually one state in that I'm interested in, and this is a one and the basic block of the Dagster as an orchestrator. Then what you will have is you will have something what is called code location. Code location is actually a server that is serving as a so to say, as a backend of the Dagster process, and definition object is actually a combination of all the base units inside of the Dagster. So you can imagine that asset, EO manager, resource, those are all small building blocks as concepts that we will take a look into in a moment. But you will see that we will go over them together, and they will all be packed into one definition object, and this definition object will be given to the code location. Okay, let me now go. I have to speed up a bit because I see that I have 25 more minutes. So practically, when we start the Dagster, what we do actually is we say Dagster dev, or the G is the alias for the Dagster client. So practically you start the server, and what is happening when you start the server is you get on the port 3000, you get a UI that is actually Dagster UI. What you have on this Dagster UI is you have different parts of the page where you can see different things. But what is important to see as a first is deployments. Deployments are so to say, what packages or what code locations are deployed to my UI or to my backend. And you will see that we have one project that is actually tutorial. And this one project is actually one code location. Inside of this code location, you can already see here is that we have 7 asset groups. And I think that if I click here on this one, you will see that what you have everything in this code location. So you have 7 asset groups. Each asset group has I don't know, 2-3 assets each, and other stuff like sensor, resources, jobs, everything what is actually in our example, what was loaded. If I now take a look into the code, and if I go to the first tutorial, I would say, we want to show the basics. So practically how a basics or basic would look like is that, and let me maybe show it first on the assets. So practically if I click on the assets, and if I click on the view lineage, and then if I go to this group tutorial basic one, those two things would be the first 2 assets that we want to make and create inside of the Dagster. How are those 2 assets created? Is practically that here in the code, you put a decorator on top of a function. And what you can now imagine is that everything what is inside of the decorator, this is actually everything this is called the asset spec. And this asset spec is the information that will appear on the UI. So this is the information of the Dagster asset on top of the asset lineage. So if I now click here on the world, you will see that I have some sensor here, and that I have some metadata here on top of this, like these kinds. And if I go and click now the view in asset catalog, then I can jump to this specific asset, and then I can see, for example, some description. Currently, description is not set. I can see, for example, some owner that is marketing, kinds is Python, and I have some automation definition. If I would now go here and add, for example, this description, I think that this I can do here, test description. Okay. If I save this, and if I go to the Dagster UI, if I go to deployments and reload my deployment, this asset, okay, okay, just a second. This I have to delete because it's not the part of the code. So we can imagine that the world asset that I can now find here will have some test description, okay? If I now go and start this asset and say, okay, I want to materialize this asset, the body of the function will actually be executed. So you can always imagine that on the start, and this is something what I can show also on top of a slide, but I will not do it with the animation. So you can imagine that I have my Dagster project that I can install in the environment, and I can start my Dagster dev. With my Dagster dev, I start practically two things. The first thing is Dagster web server. That is actually the UI which you saw now. So practically this UI, what we were looking at. This UI has a metadata in the background that is actually saving what assets are there, what was running, all the context out of the assets. And we are also starting on another side Dagster daemons. We will see Dagster daemons in a moment, but you can imagine that, for example, a scheduler Dagster daemon is actually a process that is running next to the Dagster web server and actually looking in this database and saying, is there something to run at this moment? And on another side, the important piece of Dagster understanding is the code location. That actually is a gRPC server that you could start separately, and this code location is then speaking with the Dagster web server and communicating what is actually happening. So practically there are two types or two pieces of the Dagster as the tool. The one is the front end, so Dagster web server, where you see lineage, where you can start the process and so on. And there is a second piece, which is the code location with your asset definitions, sensor definitions. So practically this code location and definitions and all the assets that you define, they are all on that slide in this piece, which is a separate server, and you have the front-end server that is on the local host 3000. And now you can imagine that when I go here and I go to the assets, and then I go to the view lineage, I can select those two assets and I can materialize them. Materializing an asset means that you start a run. This run, you can either click here on this number, or you can go to the runs, and then you will be able to see the runs here. And what you will see on this run is the events. And what are actually the events? The events are the communication between the code location and the Dagster web server, okay? And what this means now here is that you can say, okay, somebody started the run, and this run starts on the execution side, and then you can say that the code location provided some events back to the Dagster web server, and this is everything saved on the Dagster web server side, where the state of the execution and state of the runs is. Now, looking into those two assets, what I also can do is I can click on the specific assets, and I can see only the events out of this asset. And you can also see that I can practically I can see all the context and all the logs that I am providing out of my code. So if I take now into the hello, then you can see that I put inside of the context, I put my result as the log, and this is then also shown on top of the Dagster UI here, for example. What is also interesting, what you can do in this process, and this is something what I really want to show you that it's possible, that is that if you click here on the debugger and you start the debugger, okay, you have first to install the Python extension, because this is, I guess that I can install the Python extension directly. With this debugger, you will actually see the two, or you could stop the code in the different states of this loading of the Dagster. So practically outside of the, or I would say, I would call it code location spawn, and this is after materialization. And what you can now, for example, imagine is that I can stop this on both sides. And if I now, for example, try to run this, I hope this will work. The demo code will help us to work. No model name Dagster. Maybe I can start it again. Just a second. Maybe pixel show -a dev. Let's try now to see if this will start it. Okay, this is not working right now, and I'm not sure why. Okay, this will not work now. I'm not sure why. Okay, but you can imagine that now if I would start the Dagster again, you would see actually two different types that in the Dagster loading of the code location, so practically on the beginning of the code location, you should see the code location spawn print. This is this print, but you actually didn't see that print after materialization. When this after materialization print will happen is actually when I go to the hello asset, and when I'm clicking on the hello asset, then you should be able to see here after materialization print. Okay, those are two very simple assets, but I think that a lot is going on. What is also important here to say that with the dependency injection that Georg showed or said earlier, is this asset execution context that you are actually providing. So what is the Dagster execution context is that when you click materialize, and if you look again on the slide, so practically I'm clicking materialize in my Dagster web server, I'm clicking materialize on an asset, then the context out of this space is actually sent to the code location, and this code location run is done here in this process, but the context is sent over the line. And this is something what I would just like to see if I can run it here. It should work locally. Okay, so practically I started now, I'm now on my local computer, and on my local computer I clicked it with the debugger. And if I look here now, you will see that I have it also on my local host, and I didn't put any breaking point. But if I, for example, now put in tutorial, in devs, you can imagine this is the same code. If I put a breaking point here inside of the Dagster context, and I'm now starting the hello Dagster, hello key, then you can imagine that this is the code that will block in the background. So practically you can imagine that this should stop here. And what you will then see on this context is everything what comes from the Dagster frontend. So practically you will see what is my Dagster run ID, has it partitions, can I use some extra information out of the Dagster, what is my context, and so on. So practically everything what assets are selected in this run. And you can imagine that this combination of front-end and back-end running, so practically the code location and the Dagster UI, this is the differentiation that is powerful because those services are decoupled. And you can imagine that on one side you run a code location and you can have 10 code locations, but you have only one UI that is driving the code location in the front. Okay, I would say this is the first part of the basics assets. So I'm not now sure how much time we have. We have kind of 10 minutes, but what you can do, and this is maybe also something what you can do afterwards, is you can, I always try to write at least one task afterwards so that you can try out and check what is here in the Dagster. But I think that this basic concept, like you have to put a macro and you have to put the body of the function. This is everything what you see in the UI, and this is the information for the lineage, how to run, what is my metadata, what is my description. And this is actually the code that will be run when you click materialize on top of one asset. And what you also have to imagine is that we are not interested in what is running here, but we are actually interested in when this whole thing runs through, then my state and my asset is materialized, is existent. I will go on for the second one. So what I want to do, and this is maybe why this didn't work here, because maybe my if I do Pixie show.
Have you activated with shell, Alex? Also, did you install the Pixie plugin? Because only the Python plugin only understands the Python path of Pixie if you install the Pixie plugin as well. Otherwise,
but I had it yesterday. I don't think that this is too much important now, but I see that to practically, if I go here and I do browse,
yeah, you can manually set it.
I go back, Pixie, env dev
bin,
and then Python. Then I guess that this will now work, and this should work. Yes.
If you would install the Pixie add-on, this should happen automatically with the normal environment selector.
Yes. Okay. Let me now discuss the second piece of the tutorial, and this is the resources. This is a very simple example where we are using so why I have resources. A resource is something what I would like to use inside of my run, but before I actually start my code location, I want to define on which or on top of which environment I'm running. And what this means is that I can define multiple resources. Like, for example, here you can see that I have my DuckDB resource. What is my DuckDB resource is actually an instance of my DuckDB. This is a provided integration from Dagster. I don't know if this is from community of Dagster itself, but what you can imagine is that I put here the database, and then with the name of my resource, I can reference this instance of the class with the dependency injection. I can instantiate it inside of my asset. Yes, I know. 5 minutes around. Okay, we can maybe do this one and the next one, and then we are okay. And practically what you can do with this DACDB is that you can take the connection and execute some state on top of this connection. And practically what you can imagine is that depending on some state out of your environment, you can, while building the definitions, you can decide what type of resource you would like to pick. So practically either dev or prod that can come back from the environment. And then this type of the resource will be used inside of your code that is executed. And this is that dependency injection that Georg was discussing. Now, if I would go here and run go to the assets and then go to the tutorial 2 of the resources, I could materialize this, and this will take around, I think, around a minute, but the Dagster is the Pixie run minus -dev start. So this is now starting, and if I now would execute this asset, this would provide me a run. This is taking around a minute, and you will see that after that, the file that is here and the data that is here is actually saved in this dev.db DACDB that is here. Yeah. And you could also imagine that having this, what I can only do is that if I would start now, or if I would export the environment variable to prod, then my Dagster would normally take the production path, and this would go through the end. My question is, do we have a bit more time? Because I would like to show one more tutorial. And this is the metadata pipeline creation. That is practically what this means is I have some metadata, and this metadata is a definition of my jobs, what I want to achieve. So practically I have my jobs, and I have 3 elements there with same attributes. And what I want to do here is I want to iterate over those jobs from this YAML file. And I want to, perfect, thank you very much. We will stay 5 or 10 minutes more. So practically when you see this for loop, you can then iterate over the jobs inside of the metadata. And with this metadata, you could practically extend your pipeline. So if we take again the look into the name, metadata pipeline creation. So practically we have the metadata, and now if I go to, for example, if I go to the tutorial 3 on my Dagster UI, you will see that I have in my view lineage, in my metadata 3, I have 3 assets. And those 3 assets are actually those 3 assets that you can see in the jobs definition in my metadata. And now you can imagine, for example, that I can go to this page that I created, and this is something maybe interesting for you. If you go here to the database of the European Union, and you can say, okay, for me is interesting, I don't know, quality of life, and then material living condition, and then income, then you can practically take this link. You can go back to your metadata. You can put it as a new slide here. And then you can say income. You give it some table name. And I also took this table name in the definition. You can imagine that this create job function that I'm calling with this metadata is actually creating the asset. And now if I'm refreshing and reloading my Dagster UI, you will see that there will pop up the new asset that is actually income asset. And if I run it, I hope this will work. Yeah, and practically out of this, I will get in my DuckDB instance this data and can then work with this further. And you can imagine that this concept is very powerful in different ways. So you can, this is a kind of basic or tutorial about this metadata pipeline creation, where you actually do this for the ingest framework, where you do this actually for the DBT, and everything what has a machine readable metadata, you can, with a type of integration, you can convert this into the Dagster assets, and you can run it directly out of the, or understand what is in my tool out of the metadata. And this is actually exactly how all of our integrations work. So practically DBT integration is taking manifest.json here. Tableau is taking the information about the reports in the Tableau server. Ingest framework is taking some similar ingestion files, but you can then imagine how you actually build up the functionality. And this is actually where this piece of code, for example, is I have the Dagster asset inside. On the beginning, I'm sending a REST API call, and then I'm creating a table in the DuckDB, and I'm also using this resource. You can see that this code I have to write once, and this is called asset fabric, in that sense that you are kind of producing the assets, and then what you are actually providing on top of your platform is only the metadata integration. And you can imagine now that we have complex ingest framework on top of the different smaller frameworks that we are using in Magenta. Or we have a DBT integration that is provided from the Dagster itself. And looking at the time, the last thing what I want to say here is that Dagster has a lot of different integrations, and that you can imagine that all types of integrations are in some ways like either resource or EO manager or creation of the pipeline and execution of the pipeline.
Alex,
This is something what we can do.
Example, do you want to add the
Yes.
Vertex AI integration just quickly to showcase it?
What do you mean? To show it here, or?
I don't know if it's part of this list, but if you show it on GitHub, just the mini code.
Yeah. But where? Do you have it
You go
somewhere
to
here?
GitHub /Dagster community contributions or something.
Yeah, but there are a lot integration, and this one is but I would not, maybe we can send it into the chat later.
Send it to the chat,
Yeah?
but that's no sense.
You can do it in the background. Maybe I can go to the very last slide, and those are two last informations. Are we decided for Dagster because of those basic concepts that we are doing, yeah? And what we also do as a Magenta is we contribute back to the Dagster community, and we also have a local data stack that Georg can also send into the chat. This is practically a small open source version of our enterprise version of a project that we have. And what we also have to say here is that Georg and me are just part of the bigger team. We have a great team of engineers that are building such integration between the Dagster and I would say our business consumers and also our developers that are working on the platform, in order to provide better platform and better utilities on top of the platform, and faster, so to say, from source data to a value to our business. The last thing that I want to mention is there is a, I would say, very nice Dagster University that you can take, and I would really recommend the Essentials one, where you will learn about the asset concept, resource concept, EO manager concept, and all the concepts that are written on the page. And I think also that they have a very nice I would say, documentations out there where you can read about all integrations given in the Dagster space. There is also open source integrations that also Georg and me are contributing for some of them, like Vertex AI that Georg sent. But I think that if you take a look into DuckDB, you will get a code, you will see how this is used as an EO manager or as a resource manager, or for example, DBT, you will also see. And also there are courses on this Dagster University that I would recommend. Okay, saying that and looking at the time, I think we are already